Alright guys, video notes are up. Sorry for the delay, I had some technical difficulties. Fourth entry in your notebook should be discrete versus continuous relationships. Okay, go on and write that in and turn to the next blank front page. And then title it and get your date on there for me, please. If you're having issues hearing me or the sound isn't very good, let me know, send me a message and remind, and we'll kind of go from there. Alright, I'm going to go on and turn my pages. Get to the next blank one. Okay. And what did I call it? Well, the notes say continuous versus discrete. That's okay. Discrete versus continuous relationships. And then the date for today, 9/6/16. Okay. And then I'm going to just put that to the side and go on and start with our notes. Okay. Here we go. Continuous graphs are graphs where the points are connected. You can draw a continuous function without lifting your pencil from your paper. So if this is a graph, okay, and let's say that I'm plotting how the speed that somebody's car is going per hour, if they're doing 60 miles per hour. Obviously, it's going to go 60 miles per hour, so it's going to be in increments of 60, intervals of 60. So I would be able to just go straight through and not pick up my pencil. Okay? Now, discrete graphs are where the points are not connected. They're dots. Okay? Just remember dots. Sometimes you'll see them as an X. Okay? So, for example, you might see something like this. Alright, a graph like that. That would be called a discrete graph. Okay, a continuous graph is where you do not pick up your pencil from one point to the other. Alright, so let's go ahead and pause for this just a moment right here. Okay, put this to the side and let's talk a little bit more about these. These are just some kind of brief notes. So let's move to the other section for just a minute. Here we go. These right here. We'll come back to it, I promise. Those are just examples. I felt that these would be better notes. Okay, a discrete unit, okay, is indivisible okay. Well, what does this mean? It means that it is if it is divided, then what results will not exist? For example, half of a person is not a person. So like those problems with the school bus problems, and you got 3 kids left over, and you say you need another bus, okay? You can't have part of a bus. You're going to have a whole nother bus, is what it's talking about. So if it is divided, so if divided, then what results will not exist? So if divided, then what results will not exist? Sorry, remember these aren't the most exciting notes, and I kind of get a little nervous when I stand up here and have to talk. I feel crazy in the classroom, and then there's no kids in here and I'm teaching notes. All right, if divided, then what results will not exist? So example, can't have half a person. So example would be a half a person. Half a person is not a person. Okay, person. I'll work on my handwriting. Okay, so we can count. That's the biggest thing with this. Okay, with discrete graphs, you can count things that are discrete. A collection of discrete units will have only certain parts.